Let's talk about sound. Part 3. The measurement of sound. Nice to meet you. In this lesson, we will learn how to measure and express the loudness of sound. We often use the term decibel when talking about the loudness of sound. But what exactly does this decibel mean? And why is the decibel value sometimes expressed as a negative number when looking at a certain device or picture? First, let's talk about the definition of decibel. A decibel is a logarithmic unit used to express the strength or loudness of a signal relative to a reference level. The important parts here are relative to a reference level and logarithmic unit. Let's delve into this in a little more detail. Before that, as a quick piece of common knowledge, the unit called bell was named in honor of the famous Alexander Graham Bell, who invented the telephone. The prefix deci, which represents 1/10, was added to it, resulting in the term decibel. Let's come back to the decibel story. There is no need to be scared by looking at the formula. As I mentioned earlier, the important parts are relative to the reference level and logarithmic unit. The formula simply expresses this concept mathematically. Here it is, where P2 is the power of the signal being measured, and P1 is the reference power. For example, if the difference in power between two signals is 3 decibels, the power of one signal is approximately twice that of the other. Let's visualize this formula. First, let's assume that P2 and P1 have the same value. At this time, it becomes 0 decibels. If P2 is 10 times P1, there is a 10 decibels difference. As in the example mentioned earlier, if the power difference between two signals is doubled, it will be approximately 3 decibels. Now, let's consider the case where the signal that should be measured P2 is smaller than reference signal P1, resulting in a negative decibel value. We already saw that when P1 and P2 are the same, the value is 0 decibels. If P2 is 1/10 of P1, the decibel value will be -10 decibels. If P2 is half of P1, the decibel value will be -3 decibels. As you saw, the decibel is a unit that represents the relative value of the energy of the measured signal compared to the reference signal. Now, let's see what this decibel value means in a spectrogram. Usually, the spectrogram is normalized based on the part with the highest energy value. In this case, the brightest part, 0 decibels, is the part with the highest energy value, and the remaining area indicates how much energy it has relative to 0 decibels. For this sound source, the brightest spectral peak is observed where the amplitude is highest. The remaining parts have relatively lower energy compared to this peak, which is colored according to the dB scale. Let's look at another spectrogram from a different audio sample.
Decibel is a logarithmic unit used to express the intensity or power level of a signal relative to a reference level.
When someone speaks in an almost uniform tone, the distribution of energy is generally similar throughout the speech sounds. Next, let's find out how the dB unit is used in the process of signal amplification and attenuation. The picture below is an example of a filter or equalizer seen in the last chapter. You can see numbers written in dB units on the right, and in the center area, it visually indicates how much dB the signal will be amplified or attenuated relative to each frequency range of the input signal. To put it simply, it is a visual representation of how much the input value and output value differ. If the dB value is negative, it means that the signal is attenuated relative to the input signal, and conversely, if the dB value is positive, it means that the signal is amplified relative to the input signal. In this example, the green 4 kHz range is amplified by 4 decibels, and the frequency range below approximately 500 Hz is attenuated. Next, let's talk about the decibel unit that we commonly use when talking about the loudness of sound. It is easy to get confused because they both use the decibel unit, but the unit that expresses the loudness of sound perceived by humans is the dB sound pressure level, dBSPL. However, this is also a unit derived from the decibel explained earlier. To be precise, it is a unit of how loud a sound is relative to the smallest sound that a person can perceive. The smallest sound pressure that a person can perceive is 20 micropascals, which is said to be similar to the sound of a mosquito flying about 3 meters away. When talking about dBSPL, since the reference sound pressure is fixed, we can compare the absolute loudness of sounds. This chart, which you commonly see, is based on dBSPL. The quietest sound a person can hear is set at 0 decibels SPL, and relative sound levels are shown. Let me briefly summarize again what I have explained so far. A decibel is a unit used to compare the relative loudness of two signals. If the decibel value is negative, it means the measured signal has less energy than the reference signal. If the value is positive, it means the measured signal has greater energy. The unit for the loudness of sound that humans can hear is dBSPL, and since the smallest sound that can be heard by humans is always used as the standard, absolute comparison of sound loudness is possible. We have studied various aspects of sound together. However, there remain many topics worth covering in more depth. Studying and discussing sound and audio, no matter the topic, is always welcome. I will end the lecture by asking for your active interest and suggestions. Thank you for being with us so far.